So Theo, can you give us a brief introduction of Evidential tool chain?
Yeah, sure. So here is our framework for integrated software analysis called Evidential Toolchain or ETC. So what's the motivation? Traditional safety certification as mandated by, for example, DO 178 and ISO 26262 requires verification activity like analysis, review, and testing. And this verification activity is often time and resource intensive, especially if it has to produce evidence for actually the safety certification. So in this work, we provide an integration framework for bringing together different formal and semi-formal analysis tools on the top of the continuous integration framework, so that we can actually do integrated formal analysis continuously during the development life cycle of the software. Our integration framework consists of three main parts. So at the heart of the framework is this integration engine that kind of stitches everything together, and we have also these components that contains all the workflows that can be executed by our engine, and there is also a server for all software analysis tools available. So as an example of the sort of things that we do, here we are given with a two-step code review workflow. This two-step code review workflow actually automates the code review activity in software development. Currently, code reviews are done by some manual process, but here we have that we can first apply, for example, static analyzers or analysis from peer code reviewers to get an initial error report, and then this initial error report can be refined by applying more heavyweight or more involved formal methods like model checking to find a more refined tool. So in the first step, we will kind of widen our coverage, and then in the second step, actually we reduce false positives that may be introduced by applying static analyzers. So such kind of workflows can be automated in our framework. Here is a prototype implementation of our engine. So ATC. So just to show, it takes a source file, it takes a given workflow, and then it takes a configuration file for the given workflow as an input. Let's just run one sample execution. So it takes three configurations. So in the first configuration, it is applying the CP check static analyzers, followed by CBMC to kind of refine the report by using actually insight from the CPP check analysis. So now it is done, it found one false alarm, and then it continues with another. It's applying infer and CBMC. It's a bit quick here, and there is another configuration, third configuration, where it applies both CPP check and infer to do static analyzer, and it refines the initial error report by using CBMC. As we can see, we have like 3 false alarms here uncovered. So the integrated analysis is able to kind of reduce false alarms and provide more precise analysis by integrating different kind of format analysis